YouTube channel. That way you can watch it again when we're done. Okay, so you just focus on, can you see my screen okay? My Jamboard, or your Jamboard, I should say.
Yeah, it's all good.
Okay, so give me just a second. I'm starting the, all right. So we're live on YouTube, and you can watch this again on my channel, which you can find at my website, 204tutor.com. So your first question here is on page 2, and you're asking the limit as t goes to 0 of that mess. So you can't plug in 0 because that would give you an indeterminate solution. So what's your plan for this one? Have you done ones like this yet? Have you seen it like this?
I have, and like, I just like have never really known what to do.
Okay, so typically what has to happen when you see something crazy like this on the top is you have to multiply it by the conjugate of that mess. So if I take this, that's my original problem, and I multiply the top and bottom by the conjugate of that top. You understand why I'm allowed to do this?
Because isn't it just like you're practically multiplying it by 1?
Exactly. So this is just, it's just like changing, it's the same concept as saying that 1/2 is the same as 4/8, because you multiply by 4 and 4 on the top and bottom, right? It's that same concept. But when I do that, what happens is this up here at the top, you remember what happens when you have a plus b and a minus b, when you're multiplying those together, you remember what happens to the inside term?
Doesn't it cancel?
Yep, because you get a negative ab and you get a positive ab, so those are gone. So all you're left with is a squared minus b squared. Right? So all that really happens to the top here is I get this squared, and when I take the square root of something and square it, what happens?
It takes away the square root.
Perfect. So that happens there, minus this squared, which what's square root of 2 squared?
2.
Good. And then on the bottom, I have what's left over, which is just t times that mess, right? Because that doesn't, you don't even really have to multiply in the t, just write it back out again.
Got it.
Because you'll see what's going to happen soon here. Soon, at the top, what happens to this 2 and this -2?
Oh, they cancel.
So I'll do this in blue so you can see it better. So those cancel. So what you end up with is, this is really just the limit as t goes to 0 of -t over, actually, I'm going to go a little bit, one step further. What happens then with this -t and this positive t down here? What happens with those?
The t's cancel, and then it's just -1.
Exactly. Good job. That's exactly what happens. So the top is -1, and on the bottom, all I have is just that mess.
Yeah.
That conjugate. And now I can plug the 0 in, right? Because now when I plug in the 0, I get -1 over the square root of 2 plus the square root of 2, which just equals -1 over 2 square roots of 2. And then if you want to simplify that more, you can multiply the top and bottom by the square root of 2. So you get negative square root of 2 on the top, and you get 4 on the bottom. Either one of those answers is sufficient. And that's your answer. That make sense?
Yeah, definitely.
Do you see how I got there?
Yeah, I like last year we didn't really like solve problems using like the conjugate method.
Right. Yeah, so that's kind of the issue right now with a lot of students, is with COVID, the gaps in their learning. Yeah. That's why I'm offering just the one-on-one tutoring the way that I am, because it's too hard to help. I used to help multiple kids at a time and just kind of have everyone come and bring their questions, but there's just way too many gaps in everyone's understanding.
Yeah,
so
definitely.
That's why this one-on-one is kind of the way to do it. All right, next page, page 3. So now this is asking what's the limit x goes to -3. Now this problem is really just, if you'll notice, you can factor the top. Oops, let me change that color so we can see it better. You can factor that top out, and this is what really is just a hole. So this is what's called, if you remember from doing this, or maybe you didn't, it's called removable discontinuity.
Yeah, I just like knew that I had to factor, but for some reason I like couldn't figure out like what to like factor it into.
So factoring, so here's this. To factor what this is going to factor, if it's going to factor, it will factor into two linear factors, right?
Yeah.
And this is your first, this is your O plus I, and this is your last. So take your first, the only way to break up your first really is X and X, right? And for the last, there's a couple ways to break this up. It can be negative. Oh, are you sure you wrote this right? Because actually this doesn't look like it's going to factor.
It was like on like a limit practice thing that like my teacher gave us. So like that's her handwriting.
Okay, so this probably was supposed to be a -12 here.
Yeah, because like that's like number.
Or, you know what? Or better yet, when I plug in that -3, I'm going to get, it's not indeterminate, I bet. When I plug in the -3, I'm going to get 9. Oh no, it is indeterminate. Yeah, when you plug it in, you're going to get 9 plus 3. Oh, no, it's not. 9 plus 3 plus 12 all over 0. Which means this problem, the limit is infinity. Or it does not exist. I don't know how your teacher wants you to say it, but there actually is no limit for this one.
Oh, okay.
Now, the reason is, you remember rational functions? Do you remember how we graphed rational functions? One of the things you would do is you would look at that denominator, and then you would say, oh, wait, x can't equal -3. So you would draw a vertical asymptote at x equals -3. You would draw a vertical asymptote right here. Do you remember that?
Yeah.
And then your horizontal asymptote, or your slant asymptote in this case, there would actually be a slant asymptote. But what you would have is, I don't know exactly what it is, but you would have a vertical asymptote at -3, which means the limit as x goes to that either equals, you can call it in positive infinity or negative infinity, or you can just say it does not exist.
Oh, okay.
I don't know if your teacher wants you to do that for this. I think my opinion is this was probably a mistake. That 12 was supposed to be a -12 right here.
Yeah, it was like weird because like that was number 1 and there was a positive 12, but then there was a like number 2 and it was like the same problem, but the 12 was negative.
Oh, okay. Well, then this was intended. So this answer would be does not exist. The limit does not exist. Because what's going to happen is the limit is going to be, it's going to be, let me take a quick look at this on my graphing calculator. So if I plug this in, and this is also a good way to do this, use your graphing calculator to figure out what it looks like. It's not cheating, it's not illegal, it's all very, very smart. So just make sure you put parentheses around it. So if I look at this and I graph it, do you see how that's what I was talking about?
Yeah, definitely.
So there's a slant asymptote. If you zoom out, you can kind of see it better. There's a slant asymptote in there. You haven't really learned how to find that yet, so I'm not going to talk to you how to find that. But basically, you can see that when you're approaching that from the right side, when you're approaching that from here, as you're getting closer and closer to -3, the values are getting bigger and bigger and bigger. So it's going to positive infinity. But if you're approaching it from the left side, those are getting smaller and smaller and smaller, approaching negative infinity. So so actually it's not going to be infinity, it's going to be does not exist. The limit does not exist because it's approaching like this, and it's approaching this like this, and it's doing some sort of crazy slant asymptote. Okay.
Yeah, that makes sense.
All right, let's go to number 4. Consider the function. Okay, find this. So what we're doing now is we're doing what's called the definition of a derivative.
Yeah, we started them earlier this week, and I just didn't really know how to start with this one because the practice problem she gave us was like the points on the graph, but
So
this
let's
one,
do it. Yeah, let's just go ahead and do this. Let's actually plug and chug this in. So f of x equals x cubed plus 2x. And what they want us to find is they want us to find f of x plus h minus f of x. So I'm going to color code this. F of x plus h is going to be, what I'm going to do is I'm going to plug in instead of plugging in x here and here, I'm going to plug x plus h in. That makes sense?
yeah, I think so.
So I'm plugging in, that's what that means. I'm actually plugging in x plus h. Okay.
Yeah.
And then for f of x, let me do this in yellow here. For f of x, well, we know what f of x is, right? F of x is just this thing right here.
Mm-hmm.
So I'm going to subtract whatever f of x is, which is x cubed plus 2x. I'm subtracting that. And then I'm dividing that whole thing by h. Let me erase this and just draw a line so you can see. So this is the limit as h goes to 0 of that mess. Now, we're going to have to do a little bit of math over here, okay? To find what this is, we're going to have to do a little, to the right, I'm going to show you my work. So what's x plus h cubed? What does that mean? It means x plus h times.
X plus h times x plus h.
Perfect, good. Now let's do them one at a time. Let's multiply these together. And now we get, I'm going to just kind of do it fast, okay? We're going to get x squared plus 2xh plus h squared. You follow what I did there?
Yep.
I FOILed it out, okay? Stop me if I'm confusing you. Now I'm going to take this and multiply this in. So multiply that here, here, and here. That's going to give me x cubed plus 2x squared h plus x h squared. That's the blue one. That's that one. And then I'm going to, if I take this and multiply it in, it's going to give me plus hx squared plus 2xh squared plus h cubed. That's kind of a mess, right?
Yeah.
And we can just leave that like that, and then we're going to kind of clean it up as we plug it in. So now let's go ahead and distribute this here and here as well. So now I'm going to rewrite my expression here. So this is the limit as h goes to 0 of, so I'm going to write everything on the top. Remember what this was. Whoops, this whole thing right here was just that multiplied out. I'm trying to think if I can add any like terms for this. Oh yeah, I can add these together. Xh squared, there's two xh squared terms. So those become, so I'm just going to write it, I'm going to simplify it. It's x cubed. I've got 2x squared h's plus 1x squared h. You see how those are like terms? They're both x squared terms. You see that?
Yep.
So that's 3. So that's plus 3. I'm going to write hx squared like that. Okay, so I took care of that. I took care of those. Now these two right here, what are those going to add to?
3x h squared.
Good. I'm going to write h squared x because I'm going to write the x last. And then plus h cubed. Got it? So that was that. Now let's distribute this in here and add that in here. So this is plus 2x plus 2h, right?
Yep.
Okay, now let's distribute this in here. I'll write this in yellow so you can see with that color coding. So that's minus x cubed minus 2x. Okay. Are we with me? I know this is a mess. You're like, what in the world are we doing? Right?
Yeah, I get
But
it.
watch what happens. This and that gone. Right?
Yep.
This -2 and -2x gone. And now I can take an h, I can factor an h out of everything and make it disappear too. So I'm going to take an h out of, I'll do this in green. I'm going to take an h out of this, so that's just one h there, out of this, so that becomes just two h's, and out of this, so that just becomes two. Did you follow that?
Yeah.
So this is the limit as h goes to 0 of 3x squared plus 3hx plus h squared plus 2. And there's nothing left on the bottom, which is really nice because now what can I do with h?
Just plug in the 0.
And that's gone, and that's gone, right?
Yeah.
So that limit just equals, those both go to 0, 3x squared plus 2.
Oh, okay. That makes sense. I was
So
trying to.
it's a lot of tedious work, right?
Yeah.
A lot of tedious work, but that's what will always happen. And I know that that's right because I know the shortcut, which you're going to learn soon. And the shortcut, basically, it's called the power rule. Whenever you have something like that, to
Mhm.
find the derivative, all you have to do is take the exponents. See how you've got a 1 here? You take the exponents down and multiply them by the coefficient in the front, and then you reduce the exponent by 1. That's the rule.
Whoa.
Don't tell your teacher I told you. So take that down to the front. That's a 3x, and then it becomes squared because you reduce it by 1. Same with this. Take it down, multiply it. So that's just 2, and then the x becomes x to the 0. And what's x to the 0?
0.
Not 0.
Oh.
It's 1. X to the 0 is 1.
Yeah.
Anything to the 0 is just 1.
Yeah. Yeah. Yeah.
Okay, so that's how, see how that worked?
Yeah. That's.
Now I know it's shorter, I know it's easier, but math teachers are trying to teach you the why of derivatives. And what they're basically showing you, let me explain what they're showing you. This is really kind of the crux of calculus. What they're trying to help you understand here is this right here. What does that look like? What is this equation? Let me write it over here. The equation again was the limit as h goes to 0 of f of x plus h minus f of x all over h. Right? Isn't that what it was?
I think so. Yeah.
Mm-hmm. Does this look like anything to you? Does this remind you of something when you have, are these y's or x's on the top?
Oh, wise.
Yeah, those are y's. And what is the difference of the y's? What's another word we have for that? The
Oh.
difference between the y values. It's called, you remember from algebra 1, it's called the rise. And what do we do? The rise over the run. Remember that? The rise over the run is your slope. So you know what we're really doing here? We're taking an equation, like for instance, this equation right here, x cubed plus 2x. Let's look at what x cubed plus 2x is. X cubed plus 2x. That's my function, right? We're taking that function. So if I factored this out, I would get x squared plus 2. So this is going to have a 0 right here, and it's going to have no other 0. So if I looked at this function, here, let me even look at it. X cubed plus 2x. Done. X cubed plus 2x, clear. X cubed plus, whoops, don't want to do that. Delete, delete. X cubed plus 2x. If I look at that graph, and I'm going to zoom in on that graph. Okay, I'm going to take a picture of it. All right, now let's see if I can copy this and paste it somewhere. Let's see, copy. I've not done this before. I'm trying this. I just saw this little trick. Let's see if this works. Paste. Let's see, can I paste? I guess I have to add it for my image. Images. This might not be working. This might take a little bit longer than I think. Image library. That's what I want. Where are you at? Yes, there we go. All right. There's my image. Okay, there's my image. All right. So here's what I'm doing. What I'm doing is I'm taking this equation right here. Remember I said there's the 0 right there. And I'm finding the rise over run between any 2 points on the graph. So let's take this point right here. And let's take this point right here, 4. That's way, let's take 3 instead. See how high that is? See that rise and that run there?
Yeah.
That line, if I could draw a straight line between them, the slope of that line is what I'm finding. I'm finding the slope of that line. That's what the derivative does for you. It finds the slope. Can you see what's happening right here? This is the rise and this is the run. And you're taking the limit as that gets closer and closer to 0 between those 2 points. That's the concept between or behind what you're doing. I may not have explained that exactly perfectly, but that's something just to remember. What you're learning is derivatives are the rate of change on a function. That's what a derivative is. It helps you find the rate of change of a function. So you're going to learn that more. I'm not going to steal your teacher's thunder too much of it, but that's kind of a general understanding what we're doing. All right, do you want to try another one?
I didn't have any more.
Let's do some. Yeah, let's make one up. You ready? You try it.
Okay.
I'm on page 6, so let's see if you can do it. I'm going to say f of x equals x squared or 4x squared plus 3x minus 1. So find f prime of x using the definition. Find the derivative using the definition of the derivative. So you tell me what to write and I'll write it.
Okay. So do you just like start out with the equation that was on there last time, like the f times x plus h minus f of x?
And don't forget to write the limit. It's the limit as h goes to 0 of that.
Oh, yeah.
Of f of x plus h minus f of x all over h. Good. Which equals what? It equals the limit as h goes to 0 of, tell me what to write on the top. And I'll color code these. This is going to be my blue thing. What do I write for the blue thing?
Oh, geez.
I might need a little bit more space than that.
Do you just put x plus h in for the x? Yeah.
Exactly. So write 4, and then don't forget to write parentheses. X plus h squared. Got it? Now what should I write?
And then plus 3 times x plus h.
Good. Now what?
And then minus 1.
Perfect. Good. You got it. And then this one is just minus what?
The whole thing. So
what should I write?
Squared plus 3x minus 1.
Perfect. You got it. That's exactly right. All over h, right?
Yep.
So all over h. Good. Now let's do this. So that equals the limit as h goes to 0. I'm going to show the work up here.
Mhm.
So this is x squared plus 2xh plus h squared. I just distribute that, right? And this is plus 3x plus 3h. And this is just minus 1. And so this is, I got the 4 in front of all this.
Yeah.
Right? So let's write that out now. So I've got 4x squared I'm distributing this into here.
And then plus 8xh plus
Good.
4h squared.
Perfect.
And then
Plus 3x plus 3h minus 1. Now what?
minus 4x squared minus
Mhm.
3x plus 1.
Perfect. Good job. All over h. Good. Now let's cancel what we can cancel, okay?
Mhm.
So I can cancel this and this and this. That always happens, just FYI. So
Okay.
that's going to cancel with that. The -3 is going to cancel with the +3, and the 1 is going to cancel with the -1. That always happens in this kind of problem, just so you know.
Got it.
And then what do I do with the x's? Or the h's, I'm sorry.
You cancel one of them.
Gone, 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 gone. So my answer is just the limit, it's the limit as h goes to 0 of 8x plus 4h plus 3. Do I have anything else?
I don't think so.
That's it. That's it. And what's the limit of that as h goes to 0?
Is it just 3?
Not just 3, because remember, h is only going to 0, not x. H is going to 0. So that's gone.
8x plus 3.
8x plus 3. Hey, and what did I tell you? What did I tell you the trick was? What do I do with this?
The power thing.
2 times 4 is
8.
8, and x to the first. 3 times 1 is
3.
3, and that goes away. Hey, what's 0 times 1? -1.
1.
No, what's 0 times it?
Oh, 0.
Yeah, so see, that just goes away. The constant term goes away. When you take the derivative, the constant term doesn't matter.
Mhm.
Voila, done.
It's easier than I thought.
Yeah, it's not too bad. It's just a little tricky. Now, there are other trickier ones, right? Like
Yeah.
sometimes they give you like, it's not too bad when it's just polynomials like this. Has she given you other ones yet? Those are kind of trickier. I can do one for you if she has.
Not really, no.
Okay.
We
So
like
that might, yeah, that might be the next thing. Like you might have to do one where it's like I don't know, a rational function or something. And those are a lot trickier. So I hesitate to even try to do one for you because I don't want to confuse you, but that's basically how you do it. And then that other thing we were doing earlier with the limits is just, you kind of have to learn a couple tricks. You got to always have a couple tricks up your sleeve when you're trying to find limits of things.
Yeah, definitely.
All right. Any other questions?
I think that was it. But
If you want to find one, we probably have time for one more. If you
um,
want to try another one, or if you want to try another one of these, you're welcome to do that as well.
let's see.
Try to find a hard one, a difficult one.
I can never tell if they're hard or not, or if I like just didn't.
Yeah, just see if it looks different. Like see if there's one that looks different, or a limit one if you have a limit one.
I have a limit one.
Okay, tell me what. I'll write it. You tell me what to write.
It's the limit as x approaches pi over 6, and then x squared tangent of x. Yeah.
Well, you can probably just plug this in because the tangent of x is defined. It's not undefined. right? You understand what I'm saying? So
Kinda.
the tangent of pi, remember pi over 6? Do you remember your trig? Pi over 6 is your 30 degree right here.
Yeah.
So since that's 30 degrees, that angle right there is pi over 6. This side is 1. The hypotenuse is always 1, right? It's a unit circle.
Yeah.
This distance is 1/2, and this distance is √3/2.
Got
So the
it.
tangent is the opposite over the adjacent. So the tangent is 1/2 all over √3/2, which just equals, flip and multiply, equals 1/√3, or √3/3. So that's what the tangent of that is. So all this equals is pi over 6 squared times √3/3. So all you had to do is plug that in and simplify it.
Mm-hmm.
So you could simplify that as pi squared. Yeah, you can leave it like that, or write √3 pi squared over 6 times 6 is 36 times 3, whatever 36 times 3 is. 36. I'm just going to write 36 times 3. And there's nothing else that could be simplified there. So.
Oh, okay. I think.
And again, you can check that by looking at x squared tan x, right? Just going back to that graph concept. You can check that by looking at x squared times tangent of x. And if you graph that, there's that graph, and this pi over 6, if you want to punch that into your calculator, let me see if there's a way for me to, in this, to actually find the value. I don't think there is. Pi over 6, if you punch in pi over 6 into your calculator, I'm doing this on my phone, pi divided by 6 is a little over a half. It's like 0.52 roughly. So if I zoom in on that number right there, about 0.5, look at my value. It's 0.00225. 0.00, it's really close to 0, right?
Yeah.
This number right here, if you punch this number in your calculator, I bet you that's going to be really close to 0, because see how the denominator is really big?
Yeah.
And the numerator isn't nearly as big. So this number is going to be really close to 0 as well. See how I checked that? You understand the concept behind that?
Yeah, definitely.
The concept behind limit. What limit is basically saying is, as this value, as your graph gets close, as the x value gets closer and closer to pi over 6, what does the y value get closer and closer to? So imagine being on your graph and getting closer and closer to pi over 6, which is a little over 1/2, right? And what's the y value getting closer and closer to? The y value, look up in the upper left corner. The y value is getting closer and closer to 0.0024 or whatever.
Yeah.
Okay, that's the concept behind limit. Okay.
Yep.
All right. Well, hey, good job. It seems like you understand this pretty well. Now, if you need more help with this,